Well, welcome for another session. In this session, we're going to talk about PowerShell performance. Got it the subtitle, to pipe or not to pipe. It's looking at a little bit into the PowerShell pipeline and figuring out ways to optimize your scripts. If you're looking for performance, are you going to use a lot of memory, or are you going to use CPU, using split it over threads or processes, or background jobs, and we'll dig deeper into all of those things. So again, I see all of you were here last time, so I don't have to spend a lot of time on the introduction. I'm still Claus, and I'm still a consultant. I'm still an MVP. So let's get started. So, which resource to use? PowerShell is a high-level language, which makes a lot of things easy. Can this be hidden? Yep. So what are we trying to achieve? So whenever we write some code, we need to figure out what are we trying to achieve. Are we trying to do a scheduled maintenance task that run sometimes during the night? This is probably more operations-wise. Or do we need to run something that's really, really fast? And using the PowerShell pipeline doesn't necessarily make things really, really fast, because it's quite heavy, but it gives you a lot of functionality. So in your day-to-day work, if you're processing data in smaller amounts, the pipeline processor is really, really efficient, but it makes a way to handle these objects. So when you do, for instance, like a get command, that would go out and retrieve all the commands. And then the pipeline itself will process it, meaning that it doesn't start a new process, like a full process, but it has a step in the pipeline. So every command goes through and down to the pipeline processor, goes up. This is the sort object in this example that will sort the output. So of course it has a penalty that you go through this layer all the time. But the functionality you get from the pipeline processor is often worth using it. So you can have very specific examples where you need to process large amounts of data where it isn't feasible to use the pipeline. So there are other ways within PowerShell that you can avoid using the pipeline for some of this stuff. And that will speed up the script significantly, but it might be at the cost of using a lot more memory. So really what you need to figure out is finding that balance to figure out what will solve my problem. Is it really necessary with speed if it runs a job that, like a scheduled task that runs at midnight every day where nobody looks and the results just need a day? Or is it something user specific that usually actually clicks something or runs something and they wait for an input right away? So one of those things is that you as developers, this slide is probably more addressed to IT pros because they don't necessarily have that mindset. You as developer, if you develop an application, you have a lot more feeling with how the user is going to use it and thinking that way. So hold your horses. Again, a little bit towards the operations side. Before you really start optimizing your scripts, is it really necessary? Is the actual performance really, really needed? Again, the example with the schedule doesn't really matter if it takes 50 seconds or 25 seconds if there's no one there to look at it. I've seen a lot of, after talking about this with IT pros, they've spent a lot of time optimizing their scripts. But to what end, if it's a scheduled task that runs? But if it's a UI application where a user expects something in return or some input back, then you don't want to wait 50 seconds if you can take that down to 25 seconds or 2.5 seconds or something else. So the optimizations and the speed you get from using something that, of course, it's built into the language, but making it harder to read, that's always the trade-off. Do we make the scripts very complex to get the speed? But how is that when you have to maintain it further down the road and the readability of it? So that's considerations that I assume it's like normal thinking for the developers, which aren't necessarily what an operations guy would think of. So we're going to jump out. This is going to be mostly demo, so I only have very few slides for this. Built into the language, there are two, and that is a lot of people stumble on this in the beginning. There's both a for each command and there's a for each object, and they're very different. For each is kind of like what's known from other languages. It iterates through some input, whereas the for each object goes and uses the pipeline. So every object gets put to the pipeline, you see the image before, and then goes to for each. So you can do something with each object. This way, it will take one command at a time, pass it down the pipeline to the for each object, meaning that not a lot of memory will be used because it only gets one object at a time. Whereas this will load all the commands into memory, and then it will iterate over each command. So that means if you have very, very large data sets, using it this way, you really have to consider how much memory you consume. So we'll go to a demo. These are just some examples. Just have to zoom a little bit here. In these examples, I use the measure command a lot, which is a built-in commandlet or tool in PowerShell, allow you to measure a script block. So you'll measure the execution time, and I'm just outputting the total amount of seconds that it actually takes to run it. So really simple. I use the pipeline, the 1.100 means it'll iterate 100 times, and I use that to get a random. So 100 times I call get random in this example. So meaning that took 0.029 seconds to do it 100 times during the day. So doing it 1,000 times, it took 0.33 seconds. Doing it 10,000 times, 100,000 times actually, using the pipeline takes around 12 seconds usually. That should finish very soon. Again, we are taking 100,000 single objects and passing it down the pipeline and passing that to get random. Oh, it's actually done. 3.5 seconds. So, but here we're going to do the same example. First, we're going to generate 1,000,000 numbers, like iterate 1,000,000 times, and we will not use the pipeline, but we will do it as an input object. So we're going to call this is going to get passed directly to get random internally without using the pipeline. So here we had 100,000 iterations. Here we have 1,000,000 iterations without using the pipeline. And you'll see that actually doing 1,000,000 iterations takes less, almost a third of the time of doing 100,000 pipeline iterations. So these are really, really simple examples on when not to use it's possible not to use the pipeline. So if you have a lot of small objects that you need to handle, this is way faster than using the pipeline for every single iteration. Go here. Again, we're going to do some measure objects. We're going to use the pipeline here. Again, we're just going to iterate over 50,000 numbers from 0 to 49,999. That took 2.7 seconds. Again, we create all the 50,000 numbers beforehand, and we will use the for each command and not the pipeline. And I will have to mark everything so I want for it to work. And it only takes 0.2 seconds compared to 2.7 seconds. Again, some of the same considerations you should have when you're reading files. Make sure I'm in the right directory. There are several built-in ways to read files. There's get content, which has improved a lot over time. Get content, if you just do it, it will read a file line by line, and it will decorate each line it reads with information regarding what file did I read, which line am I at, and some other information, meaning that the returned object will actually get quite big, especially if this file is in a path that's really, really long, that gets appended to each object. So you could have like 100-character path string, so you get 100 bytes for each line in the file added as well. So right now we're just reading a file line by line. It's a 5 megabyte file. And as you'll see, it will read them line by line, and the resulting file object, if I do here, if I do like file.count, you'll see that the file actually had 163,000 lines. So now I read the file. So this is actually, if we do $5, oh, sorry, $5 dot get type, you actually see that the base type of this is a system array. So this is an array of 163,000 objects representing each line. So if I were to do like file 1, it would return that line. And you could do, oh, I could do get number on this. And I can see all the properties that this file has. You can see there's a PS parent path, there's a PS path, and that's what contains all this data. So for this single line, it'll actually say the parent path of the directory, the actual file name that I'm iterating through. So you can see adding that 163,000 times add a lot to the actual variable holding it. Reading it with read count 0 means that it reads everything in one go. So now you have, again, if we do file, still has the amount, but it reads all the files and it doesn't like decorate each line with the information. So again, I'm going to do it for a little larger file so we can see the differences. 10 megabytes. There's a 50 megabyte option as well, and that usually takes around 65 seconds on an SSD drive. There is a new, in version 3, there is read it as -raw, which reads everything into a single array. So that would just return a single item containing one big string. So if you want to iterate through any of the lines, you can use -raw, but if you just need to read a big blob of text, you can use the raw, and it's really, really fast as well. You know, just even doing the 50 megabytes file, if you read it in all at once, it takes 1.5 seconds. And you can say it took almost 17 seconds iterating through a 10 megabyte file up here. So again, this was the example I was showing. I'm going to go through the Windows update log. I didn't know when I tested the demos the other day. In Windows, the Windows update log doesn't exist anymore in Windows 10. So I actually had to copy one over from an older system. And if I do like this, you'll see that it's actually just considered using the raw parameter. It's just one big blob of text. So again, reading through the file, getting content. And this, we're using the pipeline to do a where search. So every line that matches this is a regular expression, a regular expressions match. that has successfully installed. So we'll iterate through my fake Windows update log, and as you'll see, it'll take 1.3 seconds. Now we're doing week count 0, and you'll see it's actually, to iterate through the 10,000 lines, it took less than 0.8 seconds, or it took 0.8 seconds down here. So really, when you're managing files, it's really important, especially large files, you figure out what you do. So, and again, you could drop directly into .NET and call the file system operations directly, which is at times faster because they have a lot more control over what you can do with them. We're going to skip this test, and you can see here we read the content into memory. In this example, we read everything into memory, and we don't use the pipeline at all. We use the for each again. So we go through each line in this. So here we're consuming a lot of memory. All this gets read into memory at once, and then we iterate through it, and we use like a regular if statement. So this is, in this example, actually slower. One of those demo things that yeah, it's hard when you only do a single test, that if the system's doing something else, you might get slower results. But this is the fastest. I run some scripts where I've run through it thousands of times, and this is the fastest solution for it. So again, the same example goes for writing to files. Gonna create data. This is just taking the string, blah blah, and multiplying it 10 times, and then multiplying it 1,000 times for each line. So data is just generate some random data. We're gonna put a text file in there. Again, there's a built-in command out file. It will output the file. Now we're just gonna go look at the file. The file is 1.95 megabytes big. Again, here we are putting each line into the file, so we're using the pipeline here. In this example, we're using the input object data, so we're just taking all the data and writing it at once, which is fast, around a second. So now I'm just gonna create a much larger variable, multiplying it by 1,000,000. Using the IO, here's the example using .NET directly, io.file, write all lines, and you see you need to know the different parameters it takes to create the. Check, 5.5 seconds. And as you'll see, the file size is 192 megabytes. So again, there's a commanded set content, which is built on this method, and that is relatively fast as well because it doesn't use the pipeline like we did out here with the out file command. Here. Even though it's slower, it will still be much faster than iterating through each object. Again, a simple example as voiding output. There's a big difference in performance. So now I have a single variable. Like if you have a string of, what's that, 15, 18 characters, there isn't much difference. So you'll see you can use the pipeline and pipe it to out null. You can assign it to null, or you can void the output entirely. Again, we create a slightly larger variable, 1,000,000 times bigger, and we can see some of the performance things here. Is using the pipeline in this example again takes 1.5 seconds, but assigning it to null is almost as fast as just voiding the output right away using the void keyword. So if you have large amount of information you want to suppress, void is usually the fastest. But if you have a few objects you need to suppress the output, out null is fine. Because still, as you saw up here, 0.0017 seconds is not a long time. And again, this is relatively small amounts of data. So I'm just going to do one more thing here. Synchronous execution. Here we have just a simple like get date. This will just get the time and date and timestamp. And we have 3 code blocks. One sleeps for 3 seconds, one sleeps for 4 seconds, one sleeps for 5 seconds, and outputs A, B, and C. And we will run these jobs sequentially. So, as you might have guessed, these will run for probably 12 seconds. But the issue here is if you do this and you use the console interactively, right now, your session is blocked. You cannot do anything until it's done. So you might want to, especially if you use, for instance, PowerShell to create GUIs, you probably want to ship this off to another run space. So the GUI, so you can do anything in the GUI while doing it. So that's one of the things with jobs. And we're going to look at that in job execution. The same example again. We have the 3 pieces of code, but instead of executing them sequentially, we're going to start a job. This is the built-in mechanism in PowerShell that you can start a job from a given process. But a job in PowerShell is, it starts an entirely new PowerShell process, meaning that it has to create a new PowerShell process that takes memory, it takes CPU, and since it's another process, data has to be serialized in order to be transferred back and forth. So there's a penalty for that, and we will see some examples of that penalty in a little while. So right now we're just running it. As you expect, before it took 12 seconds and a little bit extra. Right now we're running them as jobs. What we'll see with these like smaller delays is that the actual time it takes to create the jobs and serialize the data actually takes more time than running them sequentially. But if these tasks, if I had put 10, 15, 20 in here, it would have been a lot faster. I wouldn't get the, right now I'm getting hit that I used maybe 2, 3, 4, 5 seconds on creating a job. But if we run it again, it'll probably be much faster. Just need to check something here first. I was testing the demos a few minutes just before the session started, and yeah, it seems as if there's some kind of memory leak that it doesn't release the variables, so the system just started slowing down. After a little while, I didn't see it. I tried to run all the demos again. But right now, the PowerShell process is using a gigabyte of memory. So let's try to do get variable, right? Clear variable. Yeah. And then do GC collect. See if we can free up some memory. See if that'll be a little bit faster. Just try to run it again. When I run this and not in front of people, it usually takes around 7 seconds, between 7 and 9 seconds. So it's a little bit faster, but as you can see, this time it was around 12 seconds. We're just gonna go just right here. Just a quick overview, jobs versus run spaces. If you want to go for speed, run spaces, it's just a thread within the same process. meaning that you don't have to serialize data on transferring between the process. So there are a lot of tools, that third-party tools that have been created and scripts to automate the creation of the run space pools. So that makes it more readable. Otherwise, the PS job, since it's a built-in functionality, it's there. There's commandlets to manage it. The readability is higher using jobs. Jobs uses more memory because they start out a full process, entirely new process, and jobs serialize output, as we've been through. Again, investing more CPU, image by 2 years, whereas you can parallelize the tasks here with jobs. Some of the advantages: they're built in, better readability, give a lot better performance and synchronous execution. As you saw for very, very small jobs, the overhead is too big, but running larger processes, there's a big advantage using them. They use more RAM. They're not multi-threaded, multi-processed, but multi-process, and so on. And another big minus in my book is that there's no options for throttling, meaning if you want to run, like have an input pool of 1,000 objects, it'll try to spin off 1,000 PowerShell processes unless you handle the queuing yourself. I want to show you an example of the queuing as well. Just before we get into this, just like review the advantages of run spaces. You stay within the same processing. If you use run space pooling, it will handle the pooling of objects itself. So that's part of the run space factory. And you don't need to serialize data. Disadvantages: it's there, of course, but there are no built-in commandlets for managing it. And it's more complex. It's harder to read and harder to manage. So let's go back out of PowerPoint and into PowerShell. So I'll give you an example here. I have a PowerShell process. This is just a simple script. Here it'll just get all the PowerShell processes, and it will write when there's a new process that starts. I have omitted here that don't look at your own process and don't look at this PID, which is so when I start a look here. By the way, this is what I was telling you about earlier. This is PS readline in action. If you don't have PS readline, you can only, the history when you browse up and down, you can only get one line at a time. So if you have a multi-line input, it can't show it to you. This is, you get code highlighting, and you can choose multi-line input and just run it again. So it's really, really useful. So right now, in this, it doesn't really do anything. It just starts 10 jobs. And if you look here, you can see it starts out 10 PowerShell processes, each using around 68 megabytes of RAM, doing it absolutely nothing, containing 2 text variables. And it uses around 700 megabytes of memory to start 10 processes. So you can imagine having an input that's much larger, that would really, really fast kill the system. So you see it's spitting down on the jobs I've completed. So it's automatically removing the jobs itself and ending the process. So 717 megabytes of memory was used to start up 10 jobs that does absolutely nothing. So that's a really, really important consideration when using jobs, is that you really need to throttle them if you have a lot to do. Here's an example on how to queue jobs. Just make sure that there are no jobs lingering around. Simply by using, again, dropping into .NET, using a systems collection queue, synchronized queue, to hold the input objects. Here. Again, we decide that the max concurrent jobs can be 2. We have a function here that runs job from the queue. So we enqueue, if you manage here, enqueue, you know, of course, enqueues all items. So we iterate through all the job input and put them on the queue. And this is just the function that run it from queue, and it will register an event, and we'll have an event subscriber. So when a job finishes, it will activate the event handler, and it will get a new job will get put into the pipeline. So this is a simple for structure. Again, we can see it here. If we go to this window here, we will see, even though that the input has more than 2 tasks, it is limited to running 2 PowerShell jobs at once. So if I were to just wait for this to finish, it actually takes a long time to finish, so I will just kill it. It's done. So if I were doing set it to 3. So this is just to show you a queuing mechanism. And you will see here that it will, when it updates, it will start up a third process. Right now, still in the process of stopping the other jobs. So that's why you'll see 4 here. So it actually didn't completely finish with the other jobs. I'm just going to stop this here. So you get job, like receive job. And you can see all the, that was actually what was returned in the jobs. So this is the way using system collection queues to queue jobs, and relatively simple. So job timing, as you talked about that, this is an example created by Tobias Dalkner as a German PowerShell MVP. This is an example where we'll start a job. We will do a lot of timing, figure out when we started the job, how long it ran, how long did it take to serialize the data back. So now we're just going to run this, and we will do control R. So this is taking a regular job and running it. So here we can see it took 3.6 seconds to actually spin up the remote process, the PowerShell job. The code ran in 0.8 seconds, and it took around 0.3 seconds to return the data, to serialize the data and return it. But what we see here is that right now, the data that we are processing is just get processed. It just returns a list of all processes on this machine. This is where it gets run. So I do just select name. So this is similar to doing get process select name. So I'm only returning the name. So it's only the name of each process that gets serialized. But if I were to do this, for instance, and output the first 30 processes with all the information, that's a lot more data than just the name. And if we run it again, you see again, it took almost 2 seconds to serialize that data and return it. So if you're doing PowerShell jobs, which handles large amount of data, you really have to make sure that you filter out as much as you can in that process before returning it, because the serialization process, it will give you a penalty. The same goes for when you do PowerShell remoting. Filter as much data at the far end as possible, so you don't have to serialize all the data, transfer it over the network, and get it back. Again, now we're just going to show you the same. What did I put it? Run space timing. Going to do the exact same example using run spaces, where we'll create a new thread within the same process and outputting the same result. So again, Right now, we're actually doing a full get process, meaning that we're going to return all X object. We can see how many there are. Get process. Get count. It wasn't that what I was trying to do. So there's actually 176 processes on this machine. We will run this. And as you can see here, the time to actually return the result was 0.5 milliseconds. Whereas in the other examples, we were dealing with multi-seconds serialization timeout or times. So this is much faster. But again, the code is somewhat more complex. As you can see, you're starting new processes, but we will go through that as well. Just need to figure out too many open. Start closing. Reducing process. Here we go. So again, you can create a new process within a new thread within the same process. So this is the script block to execute. We call the new PowerShell, called the PowerShell accelerator. We create it, and we add a script, which is just this script block up here. And we do F8, and nothing happens until we do invoke. But as you'll see here with invoke, that's kind of like it locks up the, let's do a 5-second wait. As you can see, it locks up the console. So that doesn't really make sense to do it this way. So again, you could start this off in an entirely new process, but then you have to somehow figure out when the process is completed. So you have to loop through it and wait until it completes. So we run this again, the same example. We create a new thread, create the same. The execution code is the same. It's just wait 3 seconds and output's high. But now we use begin invoke instead of invoke. So right now we're waiting the 3 seconds, and it was actually handled in the. But now this is actually what is taking up what we're waiting for. This is what is tying up the console, so we can't do anything. And then you have to remember to. You have to get the output yourself. The result was high. And then, of course, you have to dispose of the close the run space and dispose of it afterwards. Top. Again, the run spaces. This is the most efficient way to multi-thread PowerShell of the built-in method. So you can see you create a new create a new process in PowerShell. And you can see the different properties of the PowerShell process. You can see it has an add argument, add command, add parameters, add parameter, add parameters, add script. And we can see that it's using the same, is similar for a run space. And it has a run space configuration, which has a lot of different methods or things you can access. So again, we saw before you had the add command, and you can add a command directly using the PowerShell process. So it'll just do get location. So it'll tell us where the location in the file system you are. Again, you use the add command, get child item, it's the same as dir. And you can add parameters, and these are comma separated. So right now it's just trying to filtering on all PS1 files, and it adds multiple parameters, and the path is C:\script. So this would be similar to writing get child item dash filter .ps1 dash path C:\script. just to get the, you can create hash tables of input parameters. Again, results in the same. And just do, yeah, it's good. It's a bit sluggish. As you will see when you do this, this is just add script, get date, and when you invoke it, it'll actually return the PowerShell object to the screen. You can of course avoid that if you don't want to. If you just want to do something that does something on other data, you probably don't want to have it come splashing back into your console. Of course, you can pass parameters as well into the to the script blocks you add. This is just building up. I'm just gonna, here you're gonna do add argument, adding the 2 parameters. Again, nothing gets executed before you actually call invoke. And you'll see it will return the 2 parameters. So handling the threads, this is still, we're in the same process. So in order to, like, spinning up multiple processes and making sure that there aren't too many concurrent threads, I will skip this and we will go to looking at the run space pools. Again, we have a throttle limit we supply. So we have the accelerator here, which is called run space factory. So that creates a run space pool where the run spaces will be run in. And the run space pool has different parameters. It has a throttle limit. It has an initial session state, so you can have different types of session states here, and what kind of host it has to run in. So this is just a regular console host. If you build your own custom PowerShell host, you could host them in the same run space pools as well. So host is just a built-in PowerShell variable for the host that you're actually in right now. So, and there's, if you did that in the console, you would have a different, say it's the console host. So again, we create a script block that will just sleep for 2 seconds. It's just going to write to the console, done processing ID, and we're just going to run through like 1 through 40. So we're going to do 40 iterations. Really, really simple again, but it's just to show that we create the run space pool and we run the different jobs, and we're just outputting it to the console. And in this example, we're actually not outputting it to the console. We're not receiving it. We're actually doing this here. So again, as I said earlier, when you're using run space pool and invoke, you have to figure out how to, when all the processes have stopped. So you have to iterate through them and see if there's any more to execute. And when you call end invoke, that will return the data. And then you have to dispose of it, of course. So what we did before wasn't very good because there's still left 40 run spaces open. So in this example, we will have a maximum of 10 run spaces. We're going to create the run space pool. Open the pool. Again, we have a simple script block that just outputs text, sleeps 2 seconds, and then it outputs the ID. Have an array of threads so we can iterate through all the threads. So whenever we create a new thread, we store that in a variable that we can look through to check if any of the jobs in that array, if they're done. And if they're done, we can call end invoke, meaning we get the data back and we can dispose of the actual run space. So right now, again, we're doing 40 iterations, just 1 through 40. And we actually have to do this while we're running it. So just gonna clear this up. Did I delete it? Yes. Clear this. Because the console hangs. It's demo day. But I guess it's supposed to happen this way. I've never had ISE crash on me until the last demo. And I wonder what it's doing right now, besides dying. I totally want you. It's amazing. Just to make sure, I tried this. I ran through all the demos 2 times during lunch break, and it never happened. So, thank you, Murphy. Just gonna restart here. And there. Let's try it again. Just gonna. Good afternoon. By the way, Tobias Welkner, who made some of the demos here, he made this really nice add-on to ISE, which has a lot of really cool functionality. I assume that most of you develop in Visual Studio. So you, in Visual Studio 2015, there is a PowerShell editor as well, made by one of the American PowerShell MVPs. So that's good, but this has a lot of the similar features like code structuring and variable debugging. You can go and whenever a variable gets visited, you can put a debug on that. So on a read and write, and you can go a lot more detailed with debugging than it's with this tool. Again, it's probably a little bit too big. Can people read this? See if it will blow up again. Are you sure you want to run it? Yes. Again, this was a simple example that I was showing you before. This will spin up a maximum of 10 threads and will just do the 1 to 40 iteration. And if you remember, there was a sleep for 2 seconds in each script block. So right now we did 40 iterations of 2 second sleeps within about 5 seconds. So this is quite efficient. If you give this to most admins, they're gonna think it's C# code or something like that, because this is quite advanced for most people. So, but it's there, and there are a lot of people that have written functions around it, wrapping this and creating functions. So you could like do get process, split pipeline that will just do all this, create all the processes for you, create all the run space pool for you, and do the iterations of each object. So again, a little bit about script profiling. I know what was his name? This was one, Eric. He showed this a similar demo earlier on, that you can compile code within in PowerShell. So right now I have this webpage on my msdn.com. There's some profiler code on the webpage. So going to this URL, I can use invoke web request. We'll just download the content of the page. So if we go here, we will see like standard MSDN page with the code sample on it, and we will do like the parse HTML get element by tag name pre inner tag. So this is actually, if we run this, it's just a fun example. If you run code, that's the actual code from that page. He's using the abstract syntax tree to iterate through the scripts and all the elements. So right now we'll actually, from a web page, we downloaded code. We're just going to put it there. We're going to create a new directory. We're going to compile it to a DLL, which is going to be on the system. So right now, yeah, did the test earlier, so the DLL is already loaded, so you can't override it. But with this simple request, you can actually download C# code directly from a web page and compile it into a DLL that's on your system. So we don't have any one of these. Then we create a module manifest file for it, which is the way the PowerShell can load it automatically. Right now, it's created a folder in my PowerShell folder under modules, and it's created the PSD1 file. It's the PowerShell data file, which describes how modules should look and what gets exported from it. So you could have private functions and public functions within your module. So now we're going to list all the available modules. So you see right now I have a binary script module that's called measure script. I will just make sure that I'm at the right location. I wasn't. And I can do measure script. This is one of the examples that we wrote earlier. This is really good for when you're debugging. Synchronous execution doesn't exist. So let's just do it there. So, so let's just do like this real quick. What's wrong? CD. I'll do it this way instead. Then I'll just in that folder. So this will execute the script, and it will measure each iteration. As you see, that was the script that took around 12 seconds with the synchronous execution, where it executed pre-prepped code. So you can see this code actually took 3,002 milliseconds. This took exactly 4,000. And the start sleep of 5 seconds actually took 4,999 milliseconds. So I don't know if this isn't exact science or if start sleep isn't precise, but it's pretty close. So you can see all the time it took. It took 12 seconds and 6 milliseconds to get through all of it. So what happened here? So another thing that was added in PowerShell v4, which was made, this is the last thing we'll go through, is a new .where and a new .for each. So now there's actually 3 ways to do for each in PowerShell and 2 ways to do where. So if you have an object containing all the services, you can actually do this now. This does not use the pipeline. This was introduced for those of you who saw the DSC demo earlier on. It was actually using this. This is made to be used with DSC, but it can be used as well because it's publicly exposed, as a way to determine which machines. So this is a where it doesn't actually use the pipeline. It's not very well documented. There's nothing real on it. So if you do like this and get an error, you can actually see what it expects. You can see it expects an expression, a mode, and a number to return. So digging through it a little bit, you'll see there's actually an enum called System Management Automation Operator Selection Mode. And you can see what options you have for that. So you can see you could be like this, statics, return the first 10 one, return the first one. But this, return the first, comment 10, return the last one, last 10. So you have a lot of options using this that you don't have using that is faster than using the regular where because you do not use the pipeline. And you can use, there's skip until, you don't have that functionality in with the regular where, and you don't have until either. So let's have all services that starts with an C. So it'll return everything until it's find one with the status of running, and that starts with the C. So it look for status, and it'll skip everyone until it finds one that is running. So you can see this is the first one with the C, and that is running. So we're not going to go out. All the demos will be put somewhere, I assume. So we're not going to go into details with that. You have the for each here. I'm just going to quickly show that. Again, you have services. You can do output different sorts of things. We need to get services. Just make sure we have the right thing up here. You can iterate through them as you would expect with for each. You could put in variables and properties here as well. You have the display name here. And it will just output the display name. So it takes input parameters. You can start a notepad process, and you can actually call methods directly on it. So right now, processes hopefully only contains one process. Oh, that's actually 2 notepads open. Do I have anything important? I do. That was the secret password. You can actually call methods directly on the process object this way as well. So this is quite powerful. So you have to be really sure that you don't just do, like, if I were to do this, hopefully I will restrain myself from running it. That would just kill every process that it could have permissions to. Again, here are some links to the some of the description on using the script profiler, and another module that was published at PowerShell magazine as well. And that's it for me. Any questions? No? Well, thank you very much then for listening to me.